Let's begin our journey into measuring space by exploring perimeter, the total distance around a shape. Whether it's a square, rectangle, triangle, or even a circle, each shape has its own unique formula. For a square, simply multiply one side by 4. For a rectangle, add the length and width, then double it. An equilateral triangle, just multiply the side by 3. Circles are a bit different. Their perimeter is called the circumference, calculated as 2 times pi times the radius or pi times the diameter. For arcs like semicircles or quarter circles, we use fractions of the circle's circumference. These formulas help us measure boundaries from garden fences to running tracks, making perimeter a practical tool in everyday life. Now let's dive into area, the measure of space inside a shape. For a square, area is the side squared. Rectangles use length times width, while parallelograms multiply base by height. Triangles have two main approaches, the classic half base times height and Heron's formula for when all sides are known. Circles use pi times the radius squared, and for parts of circles like semicircles or sectors, we use fractions of the full area. Trapeziums, kites, and even segments have their own formulas, each tailored to their unique structure. These area formulas are essential for tasks like painting walls, laying tiles, or designing parks, helping us calculate how much space we truly have. Beyond the basics, there are advanced formulas for special shapes and situations. Brahmagupta's formula calculates the area of a cyclic quadrilateral where all corners touch a circle. Heron's formula is a special case for triangles. For triangles, we can also use the circumradius or inradius to find area, offering flexibility when different measurements are known. Bodhiana's squaring method helps us find a square with the same area as a rectangle, using the geometric mean. These advanced tools are especially useful in higher mathematics and geometry competitions, and they deepen our understanding of how space can be measured in creative ways. No discussion of perimeter and area is complete without pi, the mysterious number at the heart of circles. Throughout history, mathematicians from Mesopotamia to India have tried to pin down its value. Today we use approximations like 22.7 or 3.14, but pi is actually irrational. Its decimals never end or repeat. From Archimedes to Zhuangzi, each contributed to our understanding of pi, and it appears in almost every formula involving circles. Remember, pi isn't just a number, it's a bridge connecting geometry, history, and even memory tricks, making it one of math's most fascinating constants. Wrap up, let's glance at all the key formulas in one place. Whether you're calculating the perimeter of a playground, the area of a garden, or solving advanced geometry problems, these formulas are your toolkit. From simple shapes like squares and rectangles to complex figures like cyclic quadrilaterals, knowing which formula to use is half the battle. Keep this formula sheet handy for quick reference, and you'll be ready to tackle any space measuring challenge with confidence. Remember, mastering these basics opens the door to deeper mathematical adventures and practical problem solving in everyday life.